Hello and welcome back to Universe Sandbox 2. Before we start this video, I have a few questions for you guys, my loyal subscribers. So if you go check out the description, I have a little straw poll there, or at least should by the time this is up, which will just ask a few questions regarding, basically, is this channel big enough to do a few things like Patreon and the sort? I don't think it is, but you know what, maybe, I don't know. It's kind of random when you start doing things like that, so I figure I'll just get a nice poll and answer honestly, please, so that I have a nice data point to go off of. And with that, let's begin this episode of Universe Sandbox 2, which will be, breaking physics. Now, a lot of things go weird in Universe Sandbox 2 when you ramp things up to the extremes, and that's just because simulations, you can only get so crazy before a computer just says, I'll just round it. And when there's rounding, there is error, and that can cause some pretty interesting things to happen. So the first thing we're going to do is a speed test. We're going to speed up the universe as fast as we can possibly make it go. And we're going to check the temperature of Earth right now, which is fluctuating around 15 degrees. And we're going to see if it's extremely affected or slightly affected if we just speed things up extremely fast, and we'll see that if its orbit changes at all from the, inconsistencies. So we're now going at 8 years per second. This is the fastest I can go without it completely freaking out. And if we look at Earth, its temperature is flying all over the place, but we can't really judge it until we slow it down again. So we're going to give it another minute or two of doing this. Not really a minute, more like 30 seconds. And the question is Earth going to stay pretty much the same, or is there going to be a clear difference in the orbit and temperature? How accurate is the simulation? So we are going to slow this down. And any second now, we will see the results. And actually, we do have interesting results. Earth's orbit was actually shrunk. No, actually it got bigger. Never mind. Opposite. And because it got bigger, it's actually freezing Earth a lot more than usual. The polar ice cap, the northern ice cap has basically extended to, Russia is now all snow. I mean, it was mostly snow before, but now it's all snow. Germany is pretty much in an ice age. Canada, I know it was cold up there before, but now you're literally a mega continent. Let's see how Antarctica's doing. Antarctica expanded a little bit too, but not nearly as much as the, North ice cap, and I mean, yeah, that's a lot of ice. So it does appear that we did mess up the simulation a bit by going that quickly, but you know, that's not the only thing we can mess with in this. We can mess with time, but we can also mess with speeds. So this game actually allows you to make things go faster than the speed of light, but what is the limit to that? How fast can we make something go before it pretty much just breaks? Or can we break it? What can we do? And so we are going to start this with one Earth going towards another Earth at insanely high speeds. We're talking, you guys will see. We're gonna go very, very fast. That's why I'm turning down the time, even though we are so far away from that other Earth. I'm just being careful. So we're going to go to the motion of this. We're going to go to light speeds. And we're going to start off by putting this at 100 light speeds and seeing if this is... Nope, this is not too fast for the game. 1,000, 10,000, 100,000. Okay, 1,000,000 times the speed of light. I think we're going to keep it at this speed because it's going to be very hard to time this correctly so that we don't actually smash into the other Earth. Oh, shoot. Oh, I paused it right in time. I thought I had actually missed it. So we're just going to speed this up again a tiny bit. And we're actually getting very, very close. Now, I mean, close in this sense is still pretty far away. But if you look at how fast relatively we're getting closer to the second Earth, yeah, we're close. We're actually having to go so low on the time scale that basically it's going to be 0, 0, 0, 0 soon. Yep, there are no visible numbers greater than 0 in the time step. And Earth is actually becoming slightly visible. So this is it. 1,000,000 times the speed of light collision, and we will see the results. Oh shoot, I'm being very careful not to mess this up. It's so twitchy now, like, I'm not sure how slow I can actually make this, so I'm trying to be careful here. And this is going to be a direct hit. Now we're going to keep a close eye on the temperature of the second Earth because, well, this is a fast collision. And we are going to hit any second now. 3, 2, 1. And we have collided. We do have the debris just being thrown out instantly, extremely far away. The two worlds are merging here, and it appears that, well, this is what we have left here, this Earth, which the crater is actually behind it. So that's already one inconsistency we've got. Things are coming out of it. It's actually only 15 degrees, or it's just not heating up because the time step is just so slow. Now remember, we're going so slow that these meteors flying out are actually going... Oh, they're going... Well, they're going over 1,000,000 light speeds, which means that's interesting. And this Earth is moving only at 3 light speeds, so it actually absorbed a lot of that impact. And there's no visible heat up. Even though there's the giant crater, there's no actual additional heat on Earth after that. So, we did manage to actually break apart of the physics, because thermodynamics, that definitely would have gotten very hot. Part of Africa is now gone. Also, the Atlantic Ocean doesn't exist, and oh, there goes the east coast of America. Well, we have actually completely broken that. And let's try the third way to break this, and this is going to be infinite mass. You can keep adding mass to objects in this game, which we're going to use the sun for this. Yeah, we made a little nova, but we can expand the sun again. And we're going to start sucking things in pretty quickly, and it's going to start with the meteors and planets. But as we keep making the sun bigger, the amount it'll suck the other objects in will speed up, and then they will be flung away. But then because the mass is increasing, they'll come back even faster, and so it kind of gets into an infinite loop. Oh no. We appear to have hit critical lag. Which could be solved by just deleting the inner planets, because they're the ones causing the trouble here. Oh god, where'd the sun go? There it is. Here is the sun. Oh, and I may have lagged this out too much. I'm used to pretty much going into extreme lag, but I used to be able to do this test. No. I don't think this is going to work. There is way too much lag. Though there was just something like a ring around this black hole. Oh, probably this I was going by. And, well, the sun is actually pulling this in. Let's see how fast these particles are moving. They're moving over half of light speed. So we can't actually get this black hole to make things go over the speed of light. All we have to do is increase its mass, which, oh man. Look how close things are getting now. So let's check the velocity of these now. They are going faster than light, and they are actually flinging all over the place. So now everything is moving extremely fast. But the inner, well, not inner planets, we deleted those. The outer planets are pretty much just chilling, you know. They haven't had enough time to move in that far, and they have much too much mass on this slow 3 seconds per second time scale. So I don't think we'll ever be able to get those to fall in, because the time scale's going down as much as the time is going up. It's kind of an inverse reaction we've got going on here. And so I think we're going to have to call this experiment over because, yeah, there's not much left to do here. Now, we are going to not break physics for this little thing, but we're going to do something that doesn't happen in real life, which is we're going to delete the black holes at the center of each galaxy in the galaxy collision experiment, which will require doing exactly what I just said, just deleting things, not that complicated. And now when we press play, we're going to see something pretty cool happen. The momentum from the centers is much greater than the arms, so 2 holes are going to open up as they get flung away. And if you were a space pilot in your spaceship, you could even just drive your spaceship through these rings and get like 50 points for doing stunts. Oh geez. I've zoomed in too far now, it's going super slow. Ta-da! I get like 1,000,000 points for that. That was great. Oh, let's fly back through this one. Whee. Now, if you can't tell, these are actually just still transparent pictures that are like overlaid over each other if you can't see that there's 2 there. But many of these particles make up the galaxies, and that's why they so smoothly are able to rip apart. And let's see what happens here. They have gotten to the thinnest the rings can get, and they're going to now start just expanding and ripping themselves apart. And there they go. As they spread out more and more, they get darker and darker. Actually, they're actually getting very close to merging into a super ring. And, you know, that's pretty awesome. Looks kind of like an eyeball now. Maybe not really. Or like a blue star. Oh, geez, everything's dying. That's so sad. Alone, these stars aren't that bright. Together, they are the brightest things. Oh, geez, it's getting really dark. It's like the expansion of the universe. We will just hold on to this cluster of stars. Where'd everyone go? Oh, everyone has gone away now. That was pretty sad. I am thoroughly depressed after seeing that. Those poor stars were abandoned by all of their friends. Okay, let's test something new. What happens if we just increase the temperature of something to ridiculous amounts? Now, I think it's just going to vaporize, but if it's the only object there, I think it's going to just pull itself back in because, well, it's only gravitational force in the area. So let's see what happens. We'll just heat up Earth, And now we're boiling away the oceans. And we can see all of the gas being ejected off of Earth, and Earth is now melting. We can see a nice cloud, if I put my pointer over it, of gas going out. And we will just continue raising the surface temperature. And we're going to hit the point where we seriously start to, vaporize. We can see now that the heavier elements are beginning to rip themselves apart, and Earth is gone. Now, the questionable part is what's going to happen with all of this gas. It's pretty hot still, but when it cools down, will it reform? Actually, no. All of the gas has actually disappeared pretty much. So that brings up a new question. We need to keep it coming in. So what we're going to do is we're going to start the Earth at a stupid temperature. We're going to start at 10,000 degrees, enough that it will instantly begin to vaporize. Then we're going to unpause and increase the mass so it sucks the mass back in. Let's see what happens. So, Earth is now extremely warm, and here we go. Now it is losing mass rather quickly even. But we're going to increase it at the same, hopefully same rate. And can we go faster than it is losing the mass? That's a good question, and as we get thrown further and further away as the camera, we are actually beating it. Look, all of the gas is getting sucked back into Earth now. It's regaining everything. It's actually so massive now, even its own vaporization isn't able to escape it. It's growing faster than things can escape. If we let go... Oh geez, what's going on? Okay, so I have let go, and Earth is now oh, it's very quickly cooling down. We can't let that happen. There you go, Earth. Why is it cooling down? Oh. What the heck? I don't think we can keep it hot anymore. Well, I guess that when it gets that big, it's just losing all of its heat until we basically make it a star. So let's end this off with a nice supernova. You know, there is nothing better than a supernova. Well, I mean, other than, wait, it is an explosion, so, you know, yeah, nothing better than a nice supernova, and we will see that happen in, well, soon. We're at about 10 times the size of the sun, so we will see this occur, pretty soon. 50 times, 60, 70, 80, 90, 100... 200. For some reason, I think realistic mode is not on. Strange. This has got to explode at some point. Oh geez, it has a climate and everything still because it's technically a planet. Okay, this won't work because, yeah, it's technically a planet, so we're going to just have to use the explode tool to make the greatest explosion of all time. Oh, well, that crashed. Well, I guess we can just end this video here then. Thank you for watching. Leave a like and subscribe if you enjoyed this video. And we will keep crashing games in really creative ways next time. Actually, we probably won't. We'll probably actually go to like a normal episode, but you know, sometimes you gotta think out of the box. Oh, geez, my computer is dead. I can't even, like, move my mouse. Oh, there goes the game. Music is still playing, though. Oh, there goes the music. Oh, wait. No, maybe. Oh, no.